Okay, so 4.5. Derivative. And the shape of a graph. So we learned that even though there's a critical point, there's a guaranteed local extremum, right? And today we're gonna do the derivative test. This is x, this is y. Look at this function. Okay, then look, I'm drawing the slope, right? So we call this is f prime of x is greater than 0, right? Okay, or we might think about, because the slope, right? So f prime is the slope, derivative. We talk about the slope, then positive slope, right? Because from algebra, we know that this is a positive slope and this is a negative slope, right? Okay, then what can we say the function f? F is increasing or decreasing? Increasing. Okay. Increasing. All right. Then what about this one? We have the function like that. Okay. Now I'm drawing the slope. Okay. Then we say this f prime is less than 0 because think about it's negative slope, right? Okay, then what can we tell the function is increasing or decreasing?
Decreasing.
Increasing. Okay, how about this one? So we have a graph like that. Let me draw the slope. Okay, then we say that the derivative of this function is less than 0, right? Why? Because negative slope, right? I'm sorry, I made a mistake. Huh? No one tell why I cannot think. Slow, it's like that. Sorry about this one. Slope is positive, right? Sorry about this one. This way. Then this way is negative. Sorry about that. Negative slope. Okay. Now, then the function f, how can we say that? Increasing or decreasing? Decreasing. Decreasing. Thank you. He give it to me sign. X, Y. Then we have the graph. Then the slope. Yeah, I need to think. Okay, this one, f prime is less than 0, right? Why? Because slope is decreasing, right? Slope is decreasing. Slope is negative slope. Okay, then how can you say about the function? Is it decreasing or increasing? What do you mean? I'm asking you.
Decreasing.
Yeah. Decreasing, increasing. Decreasing, right? Okay, sorry, it should be fixed on. Positive slope is greater. Okay, here must be fixed. Sorry about that. So please fix it here. Okay, so we understand graphically this one, right? F derivative of function is greater than 0, then function f is increasing. We see that the derivative of function f prime is greater than 0, then the function f is increasing. The derivative of a function, which is f prime, is less than 0, then the function f is decreasing, and same thing, right? So we see that for different, but top is the same, bottom is the same, right? Okay, we can say that. All right, let me erase this one. Okay, still graphically, we need to understand. So let me write down. Okay. All right. I can, if I fix a little bit, then it will be, oops, see. Problem is always. Okay. Can anyone recognize when I label A, B, C, D?
Are they points of inflection?
Oh, we did not get to the yet.
Um,
From the last time, it's a critical point, right? Okay, so critical points exist when the f prime does not exist or f prime of c equal to 0, right? Okay, so this is, they talk about A in this point, so f prime of A is undefined because the corner, right? How about B in this case? So this is f prime of B equal to 0, right? And I want to move C a little bit, like a flat. So yeah, probably my drawing is not. Okay. So this will be f prime of C also 0. And this one, f prime of D equal to 0, right? Okay. Those are critical points. CP. Okay. Undefined. All right, then we can say that this is f prime of A, local maximum there. Okay. How about f prime of B? What can you say? F prime of B? Local minimum, good. So this is a local minimum. How about f prime of C? Okay, how about f prime of D?
Local maximum.
Yeah, local maximum. So you guys cannot answer f prime of C, right? Because we cannot say anything, nor local maximum, neither local maximum nor local minimum, right? Okay. All right, then let us analyzing here. This part, derivative here is greater than 0 because think about the slope, right? I'm gonna just make a big one there. Positive slope, right? How about here? This part, f prime is less than 0 because think about slope b1 like that. Yeah. Okay. Then in the red spot is a flat, which is a horizontal line. Now I'm going to after b. So f prime is greater than 0 because slope is like that, right? Which is positive. How about after C? I'm going to there f prime over the function derivative, which is greater because slope is like that, right? Okay. Now after D, f prime is less than 0. Is also greater. It's less than, right? Less than. So the hard copy book made a mistake here. Okay, let me fix later. Okay. Now, we learned earlier, right? So f prime is greater than 0. What can we tell about the function f?
It's increasing.
F is increasing. F prime is less than 0. What can we tell?
It's decreasing.
Decreasing. So in this case, oh, same thing, increasing. So in this case, we say that f is increasing. And in this case, f is decreasing, right? Now, can you realize that? Can you realize if we have f is increasing, decreasing, increasing, decreasing, there's a local maximum. Can you see that? Local max. Okay, and then decreasing, increasing, there is a local minimum. Okay, then increasing, decreasing, then there is a local max. Can you analyze? Can you see? Can you just take a look there, right? Okay, so understand? All right, then we have first derivative test. It's about like this, okay? Let me write down. So I need to erase this one. Okay. Theorem 4.9, first derivative test. So suppose f is continuous function over interval I containing critical point C. Okay, so I just want to omit continuous because we know that, right? Let me denote critical point as C. Critical point C. Now we know that the function is differentiable, right? Then the first one, if f prime changes sign from positive to negative, then f of c is local maximum of f. Second one, if f prime changes sign from negative, then negative to positive. Then f of c is local. Minimum of f. Third one, if f prime has the same sign for just limit to 4, then f of c is neither a local maximum nor local minimum of f. Okay. So earlier, let me just draw a little bit here because I did not go over the here. Like that, right? So we had this part is increasing, and then also this part is increasing. There is no sign change that, right? That's why this spot, which is f prime of c, even though there is 0, there is neither local max nor mean, okay? Because increasing. Okay. All right. I want to erase this one. So let us do example so we understand this one. Positive to negative, negative to positive, just sign analysis. We have to remember, okay? Just remember this way, okay? Because we cannot remember word, okay? Positive, oops. Okay, I'm going positive, positive, negative, right? Then look, local maximum there, right? And then negative, positive, right? There is a local minimum, okay? So we remember with a picture, it's much easier, okay? That means f is increasing, decreasing, right? Same as f is decreasing, increasing, okay? All right, let me write down the example. So. Is the first derivative test to find the location of all local extreme Okay, so we want to know f prime, right? Do sign analysis. Okay, that is the first derivative test. Then we can determine the f. It's increasing, decreasing. Then we can draw. So there is a local max or minimum. Okay. Then the first of all, we're gonna find the critical point. Okay, so f of prime of x, what do you get?
3x squared minus 6x minus 9.
Okay, then we set this is equal to 0, solve for x, right? What do you get? Can you please factor out? Okay, there is a GCF, so let me do for you, then you factor out, okay?
X plus 1, x minus 3.
Okay, let us check. Positive 1, negative 3x is negative 2x. Excellent. So we have x plus 1 equal to 0, x minus 3 equal to 0, x equal to negative 1, x equal to positive 3, right? Now, we do sign analysis. So let us write down negative 1 here and positive 3. Now, what do you want to pick from the region after negative 1? You can pick any number. Each one is better.
2.
2? Negative 2, you meant? Okay, so we're gonna pick negative 2. Okay, then the derivative, which is, we need just a sign analysis. We don't have to calculate. Okay, so negative 2 plus 1, which is negative. And then negative 2, negative 3, which is negative, which is positive. Positive means it's greater than 0, right? Okay, that means f is increasing, right? This is a critical point, right? Okay, then what do you want to pick? The between negative 1 and 3.
1.
1. How about, okay, 0. 0 is always easy, right? So f prime of 0, 3, 0 plus 1, 0 minus 3. Then positive, negative, which is negative. Negative means f prime is less than 0. That is, f is decreasing. Oops. Decreasing. Okay, so what do you want to pick after 3? Number
4.
4. Okay, so since we know that, I'm not gonna write down. So we substitute 4 into the f prime of x. So 4 plus 1, which is positive, and 4 minus 3, which is positive. So we get positive, which is greater than 0, right? So here, f prime is greater than 0. That means f is increasing, right? Okay, look, increasing, decreasing, right? Okay, increasing, decreasing. So draw that. Decreasing, okay? Then increasing again, right? Cannot do that. Increasing, decreasing, increasing, decreasing. Ah. Screw here. Second part is we get the negative, so it's less than 0. Okay. So here increasing, decreasing, decreasing, increasing, right? Okay. So this is we consider local max, right? This is a consider, we say that local minimum, right? Okay. So let us conclude. Let me use the space under there. So when x equal to -1, then local minimum, local maximum. Maximum, right? When x equal to +3, then local minimum there, right? Okay, so this graph looks like this. Let me just sketch. I'm so scared. Like that. Let me draw the x-axis, y-axis. Where is 0 here? Okay, so let me draw this one. That one is maximum. And then like that. And then when x equal to 3, I want to make a like that. Okay? Okay, let me erase this one. Okay, let us do one more. It's a fraction power. Okay, second one. I'm sorry. Let me check the chat later, okay? Find the location of all local extrema for f of x equal to 5x to 1/3 minus x to the 5/3. Okay, now we're gonna find the critical point first. Okay, then we set it up and then we do sign analysis. Then we determine whether the function f is increasing or decreasing, then we can notice that whether the local maximum, minimum exists, right? So here, so what is f prime of x? Derivative of the function. What do you get? Come on. Come here. Hurry up. Don't have time. Huh? Which one?
5/3. Oh,
Thank you. Excellent. Go ahead.
to the negative 2/3 power.
It's the negative 2/3 power. Good.
And then minus 5/3 x to the 2/3 power. Not negative.
Very. It's negative?
No, it's not negative.
Okay, then let us simplify this one. So 5/3 negative power we bring down to the denominator. Then we have 5/3. This one looks weird. So let me write it this way. And then x to the 2/3, right? And we're gonna make a common denominator. Okay, so common common denominator will be x to the 2/3, right? So thank you. It's minus. I did not make a mistake. Right? So this will be 3x to the 2/3, and then 5 minus, so we make a common denominator, is x 2/3, x 2/3, right? And which is x to the 4/3. So we get that. Okay, now, and we missing 5, right? So then we can factor out with the 5. 1 minus x to the 4/3 over 3x to the 2/3. Okay, so critical points, how do you find the critical points? Also two definition. Set x equal, set to the 0 where? Okay, so we have two definition of a critical point. One is f prime of x equal to 0, right? And f prime, second one is f prime is undefined, right? So the numerator is f prime of x equal to 0. We can set that, right? As your classmates say. And solve for x. Now, secondly, we have the f prime is undefined. That means the denominator equal to undefined, right? So we set denominator equal to 0, then that is undefined, right?
Yeah, it's if you plug in 0, it's undefined.
Then we know this, in this case, x equal to 0, right? Now, top one, we say that 1 minus x to the 4/3 equal to 0. And that is We move to 1 equal to x to the, how about this? Cube root and fourth power there. How about that, right? Now, we want to solve for x. How? Cube, isn't it? So we get 1 equal to x to the fourth power. Now, how do we solve for x?
You take the fourth root of both sides.
Take the fourth root to both sides. Right? For the other side is plus minus, right? That's why I did not multiply the power at one time, because you might miss that, right? So this will be x equal to plus minus 1, okay? Now, we do sign analysis. So here, 0, -1, and +1, okay? All right. What do you want to pick after -1?
-2.
Thank you. Then we have 5, 1 minus x to the, oh no, not x. I need your help because this is a power, right? A fractional power. So this is a -2. And then 4/3 over 3, -2, 2/3. I think we cannot make a sign analysis here because the fraction. Or I can think about just a cube root over fourth like that. So what do you get this one? Just a positive number, negative number. Just please give it to me like that. What do you get? You don't know?
It's negative, I think.
It's negative. So it's negative here. So f of prime is less than 0. How about this? In this case, between -1 and 0. What do you want to pick? Tell me, what do you want to pick?
1/2.
Okay, she wants to pick -1/2, right? 1/2, -1/2. Okay, then what did you get? Is the negative or positive?
Positive.
Positive. Then f of prime is greater than 0. And then what do you want to pick in this case? Between 0 and 1?
1/2.
1/2. Okay, I think this is a positive as well. What do you think? Because sign, right? It's a cube root, but anyway, we do fourth power. So it's positive. Is it correct? Okay. And then what do you want to pick? The last interval. Last interval.
2.
2. So if you pick 2, sorry about this. It's the same thing with the left side. So it's we get negative. Okay. So this means f prime is less than 0. Okay, f prime is less than 0 means f is decreasing, right? F prime is greater than 0 is f is increasing. So does it here. And f is decreasing here. Okay, so if there is the same sign, then they don't change anything, right? Let's see. Decreasing, increasing. Okay, so decreasing, increasing. Decreasing, increasing, like that, right? And increasing, decreasing, increasing, decreasing. So like that. So this is the local max. I mean, sorry, mean. This is a local max. Ah. Okay, let me draw the graph, the roughly here. And then I need the x-axis, y-axis, -1, so it's about here. Ugly. But I try to make the oops more. So I want to make it here is a local max. Okay. And I want to make here is a local minimum. Okay. And looks like there is a vertical tangent line, right? Can you see that here? Vertical tangent line. Yeah. We know that when x equals to 0, there's the f prime is undefined. That's why, right? Okay. Looks like messy. Okay, let me erase this one. All right, let's move on. We have the vocabulary, concavity. So let me write down the definition first. Let f be function and differentiable. open interval I, we know I is interval, we know that, right? And if f prime is increasing over I, we say f is concave. Okay. Why? Okay. Can I write down? Concave over f if f prime is decreasing over I, then we say that f is concave over I. Okay, all right. Let me just explain to you about just the vocabulary concave up, concave down. Okay, so concave up is like this in general, like a parabola, open upwards, right? So we might think hold water. Okay, now concave down is like a parabola, open downwards. So we might think spill water. Okay, but not obviously like a parabola, open upwards, open downwards. If you took statistic, there's a bell shape, right? Looks like that. Okay, and we say that this part is concave up, okay, and this part is concave down, and this part is concave up, okay. Make sense? Okay, then let me explain what's the relationship with the f prime with the concave up and concave down, okay? So let me draw this one. We know f prime is increasing, looks like that, okay? Positive slope, right? Because look, the slope is smooth and steeper. Okay, then we say this is concave up. Let me denote just C, concave up, CU, all right? How about this one? The graph is like that, then they say the f prime is decreasing. Okay, then same concept, the slope is steeper, then smoother, okay? So, okay. we call this is concave down, right? How about this one? So also this one, f prime is increasing. Okay, look this one. It's negative slope, right? But negative slope, positive. So negative slope, steep, and then smoother. Okay, then this is concave up as well. Now last one. The graph like that. Then looking at the slope, we said that, let me write down this one first. We said f prime is decreasing. That is, we have a negative slope, smoother to steeper. Okay. So think about the number. Just plug in the number. So m equal to 2, m equal to 10, right? Bigger number, more stiff, right? In negative, smaller number. Okay, let me see. M equal to 2, m equal to 10. So more steeper, right? M equal to negative 2, m equal to negative 10. So m equal to negative 2, m equal to negative 10, more steeper, right? Okay. All right, let me erase.
Is the top right graph? I thought it was f prime increasing or no?
Oh, so we talk about the slope for the derivative. This is not f we're not talking about, okay? If
Okay,
f is
yeah.
increasing, okay? Yeah, good point. So f prime, we talk about the slope, okay? Steeper to smoother. That's why decreasing. F prime is decreasing, okay? A little bit confusing, I understand. Okay, then we have the test here, concavity test. Okay. Let me erase this one. So theorem 4.10 test for concavity. So concavity means concave up or concave down. Okay. And the f of a function, we know that, and twice differentiable. Over the interval I, then if f prime over x is less than, greater than 0, then f is concave up over I, okay? So it must be second derivative, not the first, okay? Because we talk about the second twice derivative. If second derivative less than 0, then f is concave down. Okay, so let us talk about this one. If we have the graph like that, okay, then this is a concave up, right? And this is a concave down. We know that. Then we say that this will be f prime is less than 0. Then f second prime is greater than 0. Okay. And this part, f prime is greater than 0. Okay. And still concave up, right? F second prime is greater than 0, right? Okay. Now I'll move on, concave down. Then looking at the f prime is positive, so f prime is greater than 0. Okay. Now concave down, so f second prime is less than 0. Don't get confused. All right. Then also here, well, I don't want to do that. Okay. But then what I want to talk about here is we called inflection point. Okay. Inflection point means when concavity change. So either concave up to concave down or concave down to concave up. So let me write down definition. If changes concavity, the point f of A is an inflection point. Okay. Okay, so let me erase this one. We have the function. Determine all intervals where f is concave up or concave down. Okay. List all inflection point for f. Okay, so concavity, we want to find concave up, then f of second prime is greater than 0. Concave down, then f of second prime is less than 0, right? So we're gonna do that. First of all, we're gonna find the first prime, then second prime, okay? So what is f prime of x? F prime of x?
3x cubed or squared minus
3x squared minus 12x plus 9, good. Now f second f second prime,
Six x minus 12.
so 6x minus 12, right? Then set equal to 0. So we're gonna find, it's the same as the critical points. So when we had first derivative, then we set equal to 0, then when we find the critical point, f prime x equal to 0 or f prime is undefined, right? So same as the second derivative, we set that equal to 0, find the 0. Also, f second prime is undefined. But in this case, we have just a polynomial. So we don't have the fraction. So we don't have f second prime is undefined. Okay. Then what is the x in this case?
Two.
2. Okay. Then we do like a sign analysis. So we have a 2 here. What do we want to pick to between this after 2?
1.
1, okay. 0 is always easy, but 1, yes. Okay, so 6, 1 minus 12. So what do you get? It's a negative, right?
Yep.
F second prime is negative, means less than 0. Okay, then less than 0 is telling us concave down, right? All right, then f second prime, we do, what do you want to pick? It's up to you.
3.
3, okay, 3. Now we plug in 3 there.
Positive.
Then it's a positive, good. Then f second prime is greater than 0, which is concave up, right? So since concavity change at 2, right? So we call this is the inflection point, right? So let us arrange concave down when the interval is negative infinity to until 2, right? Then concave down is 2 to positive infinity. And then inflection point when x equal to 2, okay? Or by definition, we have an order pair. So when x equal to 2, what do you get? It's a lot of. Okay, plug in the original function f. Then 2 cubed minus 6 times 2 squared plus 9. Then because a lot of work. It's a 32, okay? So this is the inflection point. Okay, so let me draw roughly for this function. It's like that. Not good. Like this, okay? So this is the inflection point. All right. Let us do second derivative test. Then we are done, okay? Let me erase this one. Okay. So let us talk about the graph first. We have a graph like that, okay? We know this is a concave down. We know this is a concave up, right? But then look, okay, since I'm talking about the concave down, So concave down is f second prime is less than 0, right? Concave up, f second prime is greater than 0, right? Or look at the slope in this case, which is f prime. Since they said a here, f prime of a equal to 0, right? And looking at this slope, then they talk about this is b. So f prime of b equal to 0 as well, right? Then can you notice that? When concave down, there is a local maximum. And when concave up, there's a local minimum. Okay. So second derivative test. So first derivative test, it's about the f prime of sign analysis. So we can conclude the original function is whether increasing, decreasing, right? Then second derivative test, let me write down. Second derivative test, okay. Suppose f prime c equal to 0, then second prime continuous containing c. Okay, so in this case, critical points, all right? Then we have f second prime of c is greater than 0, then f has local minimum, okay? And second one, f second prime is less than 0, f has local maximum. And third one, equal to 0, we cannot say anything. We need to go back to first derivative test. Test is inconclusive. All right. Okay, let us do example. So this is the last problem, okay? Use the second derivative to test. Find the location of all local extrema, or f of x equal to x to the fifth power minus 5x to the third power, okay? So we're gonna find the critical point. So what do you get? F prime of x.
5x to the fourth minus 15x squared.
Okay, then we set this is equal to 0 and solve for x, right? Okay, then let me help you out a little bit. 5x squared, then x squared, right? Then you do. Okay, let me do it. Okay, then we have x equal to 0 because x squared equal to 0 is x equal to 0, right? Then x squared minus 3 equal to 0, then x equal to plus or minus square root 2 over 3, right? Okay, now, second derivative test said that we plug in the critical point into the second derivative, okay? And then we evaluate whether the greater than 0 or less than 0, okay? So let us find out second derivative. What do you get? Hurry up. I did the first one. You do the second one. Hurry up. 1, 2, 3. Time's up.
20x cubed minus 30x.
Thank you. Then solve for x, right? So so 10x, 2x squared minus 3 equal, right? All right. We not really find the second derivative. We don't need this one, right? We just need so we're gonna just plug in 0, right? So 20, 0 minus 30, 0, which is 0. Can you please do that for me? Okay. So negative square root of 3, what do you get? Second one. No one calculate? Okay, then let me
Yeah, I
use
can't see the screen.
Okay, let me use a book then. Oh, someone got it already. Okay, good. Thank you. Thank you so much. So he said that negative 30 square root of 3. And this one is positive, so we get the positive, right? But then look, here is inclusive. The test is inconclusive. And this one is less than 0. Less than 0 means concave down, right? Concave down, then think about that. Concave down, then local, excellent, local maximum, right? Okay, and this is greater than 0. Second prime is greater than 0. That means concave. I'm sorry, greater than 1. Yeah, I said it, right? Oh my goodness, greater than 0. concave local, concave up, then local minimum there, right? All right. So, rush it through again. Okay.